In this video, we want to see how to balance complete combustion of alkane. That is, we will balance alkane with odd number of carbon and even number of carbon. Okay, let's put this one here as our check. You will understand it by and by. By odd, just say the single. Then by even, when you want to balance even number alkane with even number of carbon, say you double the number of moles of the reactor. We will get to understand what that means, because in this video, check with formula. Alright, now let's go. For example, we want to combust methane, that is, we want to burn methane completely in the presence of oxygen, which means combustion means addition of oxygen to a substance. So, by complete, we mean in the presence of sufficient oxygen or excess oxygen. Okay. Now, the skeletal reaction is carbon dioxide and water will be formed. Water in gaseous form, carbon dioxide is a gas, oxygen gas, and methane gaseous form. Alright? Now, looking at this, we have only one atom of carbon here at the reactant. Then, from the product side, one atom of carbon, which means there is no issue with that. Coming to hydrogen, there are 4 atoms of hydrogen at the reactant side, and this is the only hydrogen here, 2 atoms of hydrogen. To balance that, we put 2 here, that is 2 times 2 make 4. Alright, from here, from the product side, we have 2 atoms of oxygen here plus 2 atoms of oxygen to give you 4. And this is only 2 atoms of oxygen here. To balance that, 2 times 2 making 4. So this is complete reaction, the complete equation for the reaction of methane in the presence of oxygen with sufficient oxygen, which we call complete combustion of oxygen. Yes, to check this after exam, that is, you can use your formula to check your hydrocarbon, say, plus oxygen to give you CO2 plus water. Yes, this is X plus Y over 4, and this is X mole of carbon dioxide and Y over 2 moles of water. Now, looking at this, going back to methane, here we have only one atom, this CH4 plus 1 atom of this, of carbon, plus 4 over 4, that is following this, of oxygen, to give you 1, that is only 1 like this, CO2. So once it is 1, now remove it, plus Y stand for 4, that's 4 over 2 of H2O, and this will give you CH4 plus 1 plus 1 of oxygen to give you CO2 plus 2 moles of water. So looking at this very well, so this is 1. This is CH4 plus 2O2 to give you CO2 plus 2 moles of water. When you look at this very well, it looks like this. So that is how to balance using formula. Now, combustion of ethane. Ethane, that is C2H6. Yes, when we want to combust this completely, that is, want ethane to undergo complete combustion, that is C2H6 in the presence of sufficient oxygen to give carbon dioxide and water. Gaseous form, gaseous form, gaseous form, gaseous form. Yes, the sharp way to go about this is where we are going to apply our thing here. Once you know that you have even number of carbon to balance, the sharp way to go about that is just introduce 2 moles of your reactant. 2. And from there, which means you have 4 atoms of carbon. Therefore, from the product side here, carbon, to make it 4, this will become 4. 4 carbon and 4 atoms of carbon. Now, from here, you have 2 times 6, 12 atoms of hydrogen. And there are only 2 here. Make it 6. This 2 times 6 times 2, 12. 2 times 6, 12. So, carbon and hydrogen settled. Coming to oxygen, here you have only 2 atoms of oxygen. But from the product side, oxygen here is 2 times 4 times 2, 8, and here 6. So 6 plus 8, that is 14. To make that 14 atoms of oxygen, this is 2 times 7, making 14. That is just a simple way to balance that. However, like I said, if you want to introduce your formula to check after the examination, the formula is CX8Y plus oxygen X plus Y over 4 of oxygen atom to give you X of carbon dioxide plus Y over 2 of water. Yes, let's try to do that. C means C2H6 plus X stand for 2, 2 plus Y stand for 6, 6 over 4 of oxygen atom to give you X stand for 2, 2CO2 plus Y stand for 6, and that is 6 over 2 of water molecule there. Now, this stands as 6 plus 2 plus 3 over 2 oxygen atoms to give you 2 carbon dioxide, 2 moles of carbon dioxide, and 3 moles of water. Now, looking at this closely, this becomes C2H6 plus, this is over 1 from our elementary mathematics. This gives us 4 plus 3 over 2 of oxygen atom to give you 2 moles of carbon dioxide, 3 moles of water. Yes, this gives us C2H6 plus 7 over 2 of oxygen atom and 2 moles of carbon dioxide, 3 moles of water. Yes, this is correct, but to make your number of mole of oxygen here at the reactant, multiply 2 by 2. Multiply all 2 by 2 so as to eliminate this fraction. So this becomes 2 moles of carbon, that is methane, 2 moles of methane plus 7, that is 7 over 2 times this 2. Cut it off and you have 7 oxygen atom, and multiply 2 times this 2 times 2, making 4 moles of carbon dioxide, and 2 times 3, 6 moles of water. Looking at this closely, so what we have above, 2 moles of methane, 7 moles of oxygen, and 4 moles of carbon dioxide, 6 moles of water. Therefore, the idea is, once you discover that you have even number of hydrocarbon to undergo complete combustion, just put 2. Let's look at another even number of hydrocarbon, and let's say C4H10 plus oxygen to give you carbon dioxide and water. Yes, this is another even number of carbon. The sharp way to go about that is double the number of mole of your reactant. Okay, which means we have 4 times 2, 8. 8 atoms of carbon. To make these 8 atoms of carbon, we put 8 here. Yes. How many atoms of hydrogen now? 2 times 10, 20. 20 atoms of hydrogen. We have 2 here. That means 2 times 10, making 20. Yes, let's look at the number of oxygen atoms at the product side so as to balance the number of oxygen atoms at the reactant side. Yes, 2 times 8 times 2, 16, plus 10, that is 26. 26 divided by 2, that is 13. 13 times 2 will give you 26. That is 13 times 2 will give you 26. This is 26. Sum up 30. Therefore, this is a complete how to balance complete combustion reaction of butane. Now, going by our formula to check after examination. The formula remains H plus X plus Y over 4 of oxygen atom will give you X mole of CO2 and Y over 2 moles of water. Alright, let's try to balance out. Let's substitute this with butane. So we have C4H10 plus XX4, 4 plus 10 over 4 oxygen atom to give you 4 for X, CO2 plus Y is 10. 10 of 2 over 2 of water, and this is C4H10 plus 4 plus 5 over 2. That is 5 over 2, that is when the top phase, 5 over 2 of oxygen atom to give you 4 moles of carbon dioxide, and this is 5 moles of water. 5 moles of water. Okay, and looking at this closely, that means C4H10 plus this is over 1, and this will give you 8 plus 5 over 2 of oxygen atom and 4 moles of carbon dioxide, 5 moles of water. Alright, this is C4H10 plus 13 over 2 of oxygen atom and 4 moles of carbon dioxide and 5 moles of water. Yes, this is correct. But try to make this one a whole number, that is oxygen a whole number. You multiply all through by 2. Multiply all through by 2. And that will give you 2C4H10 plus 13 O2 then times 2, 8. 8, that is 4 times 2, 8 CO2 plus 5 times 2, 10 H2O. If you look at this one closely, it's like this. Which means when you have even number of carbon, that is your hydrocarbon to combust to undergo complete combustion, you double the number of mole of reactants. Thank you.
If you found this video educative, please like, comment, share, and subscribe. Thank you.